Okay, so we have this exam question. So vector, so June 19, paper, obviously paper 2. It's question 26 mark question. It looks interesting. All right. Let's go through it. Let's get my pen working. Okay, so CDF is a quadrilateral. Okay, CD is LA, D to is little b, F to C is A minus B. Express FE in terms of little bit. Okay, right, straightforward. So FE is FC plus CD plus DE, which is simply going to be, so A minus B plus A plus B. To A, which makes sense given that it's parallel to CD, which is the vector A. So parallel vectors, as we know, are multiple each other. Straightforward. So F to E is just 2A. Let's make a note of that here. Okay, let's make some room. 2A. First bit straightforward. Okay, then says that M is the midpoint DE, X is the point on the line FM, such that Fx to Xm is n to 1. So this is in the ratio n to 1. Okay, we've got to try and basically find the value of n given that CXE is a straight line. Now that means it's a straight line. It means CX is some multiple of XE. Straight line, that's a mean parallel to each other, okay? Share a common point X. So it just means that CX, CX is some multiple of XE. Okay, like so. Now, let's do that then, guys. So what we're going to do is find the vector CX. So we know the vector CX. Let's go. Let's go C to F plus F to X. Remember, guys, the way this works, basically, first of all, C to F is obviously negative of FC, so it's B minus A. Now, F to X, guys, remember that n to 1 ratio means you've got n over n plus 1 lot to the vector Fm. Okay? So that's going to be B minus A plus n over n plus 1. It's a bit neater. And we're like n over n plus 1 lot to the vector Fm. Okay. Makes sense. Okay. So Fm, F to M, is F to C. Should write this down really. So F to C plus C to D plus D to M. And D to M is a half of D to E. Okay, so B minus A plus N over M plus 1 lots of, so for F to C is A minus B plus C to D, which is just A plus a half of B. No bracket needed. Okay. So let's tidy all of this up now. So look at your A's. Okay, so you've got minus A. Take out a factor of A. So minus 1 And then look what we've got. We've got 2a's in the bracket. We've got 2a's multiplied by n plus 1. So you've actually got 2n over n plus 1, lots of a. Yeah. That's the a's done. That one's done. Yeah. And then same with the b's. You've got 1b. You've got minus b plus a half b minus a half b times by n plus 1. So you've actually got effectively minus n over 2 lots of n plus 1 b. Okay, so let's make these simplified fractions, guys, to help greatly. So all over n plus 1 times top and bottom by n plus 1. So you've got minus n minus 1 plus 2n is n plus 1. Just make it a single fraction, guys. Lots of a. Same here. Denominator is now 2 lots of n plus 1, so 2n plus 2. That was in the bottom. Yeah. 2n plus 2 minus n is just n plus 2. Lots of b. So that is your vector cx. Okay. What we need to do now is find the vector x to e and then work out what that multiple is. Okay, do it from there. We have to find them from there. Make some difficult question, guys, this one. Make some room. Okay, so now we're going to work out the vector x to e. Now to work out x to e, I think we should probably just go x to m plus m to e. Yeah, which is just a half b anyway. M to e is a half b, straightforward. So this is going to be, so this time x to m is 1 over, isn't it? 1 over m plus 1 lot to the vector fm. M to e, she knows a half b, straightforward. Okay, so this is 1 over m plus 1 f to m. So it's our f to c, remember, which is our a minus b plus our c to d, which is just a. And remember, we're going to add in a half b, remember. It's d to m. Yeah. That's going to be, we simplify all of this, guys. So look at your a's. You've got 2a's multiplied by m plus 1 over n plus 1. So you've got 2 over n plus 1a. Look at your b's now. So you've got minus b plus a half b is minus a half b multiplied by n plus 1. So there's your yeah, and then you got your half outside. Okay. So you effectively you got a half minus how many? Because minus b plus half b is minus half b. You've got 1 over 2 lots of n plus 1. Be careful that one. B. So you've got 2 over n plus 1a. Now, again, you need single fractions, guys. So you times time up n plus 1 the first fraction. N plus 1 minus 1 is n. So n over 2 lots of n plus 1b. Okay, so that's the vector x to e. Okay, good. Okay, so we're nearly there now, guys. This is the important part. The important part now, What's around that? Is that we know that these two vectors are parallel, okay? Because on the same straight line, it tells you CX is a straight line, share common point. So CX is a multiple of the vector XC. Now, for example, if I was to say to you, this is the way this works, guys. If I imagine we had 2a plus 3b and a parallel vector, i.e. a multiple, being, let's say, 4a plus 6b. Yeah? Now, clearly what's happening, if you look at it, is if I'm doing 4 divided by 2, so obviously 2 would be the same as the 6 divided by 3, which you would expect because the multiple's 2, as you can see. So 4 divided by 2, let's write this down, which is what I mean by that. So 4 divided by 2, yeah, the coefficient of A is equal to coefficient of B, 6 divided by 3, obviously, because the multiplier is 2 to get from this vector to this vector. I'm times by 2, it's a scale factor, isn't it? Okay? So it works the same here. It works the same with this question. It's how I'm going to find my n, you see. So what I'm going to do, I'm going to do this coefficient divided by this coefficient. Okay, so I'm going to write, or set rather, n minus 1 over n plus 1 divided by 2 over n plus 1. I know that it has to be equal to, as illustrated previously, this coefficient, n plus 2 over 2, n plus 2, divided by this here, guys. That is what I need. That's what I'm going to do. So I'm going to find n. So n plus 2 over 2n plus 2 simply divided by my n over clearly 2 lots of n plus 1 is 2n plus 2, which is nice because they will cancel. So that's nice because I've got a cancel here and a cancel here, cancel here, cancel here, makes it quite straightforward. So we can say that n minus 1 over 2 definitely equal to n plus 2 over n. Fraction to fraction, you know we've got to cross multiply. So we have to cross multiply. So n minus 1 times n is n squared minus n is equal to 2 lots of n plus 2 is 2n plus 4. That's quadratic in terms of n. Let's move this over here. Let's come down here now. So n squared minus 3n and minus 4 is 0. Clearly n minus 4, n plus 1. N is minus 1. Can't happen. N can't be negative. So our n will be 4. Okay, so that tells me that fx to xm is in the ratio 4 to 1. Which looks about right, is it? Okay, let's check that one. Yeah, there's your n is 4, guys. And you're back to 2a for part A. Okay, thank you.